Okay, well, thanks very much, Dave. Uh, one little addendum on that Nobel Prize stuff. I was a member of what's that? That's good, thanks a lot. Of a group of about 1,100 people, and I suppose this is a little bit humorous thing. Well, yeah, I got this, and I went to my chair and was asking for a raise, and well, I was in on that award. As I said, there were 1,100 of us. He looked at me square in the eye and said, "You're a Millie laureate, not a laureate." So anyway, thanks very much. It's great to be here. It's a really nice turnout, and we'll get on with things. Oh, one thing I need to find out is how to page this up and down. And for that, I need my glasses. Okay, is it just the arrows here? Okay, just, yeah, that and that. Okay, well, real good. I want to talk a little bit tonight about something that's been on my mind for, gosh, more than 20 years, but I've never published anything really on it. And that's I think that Map Society is a real good place to work on this. I've given a few talks before on this topic, and I had to rely a lot on highly technical stuff because it was usually the permafrost scientists. So I have tried to make it a little bit more understandable for a public lecture with not so much detail. But anyway, let me read the title. I have a funny angle here. Echoes from a Thawing Cold War. Reevaluating the cartography of permafrost. And I'd like to introduce my co-author on this, a young woman named Kelsey Nyland, who has a doctorate in geography from Michigan State University. She got her degree about 5 or 6 years ago. And she's currently an assistant research professor at George Washington University. She lives in Okinawa. Through the wonders of technology, you can actually accomplish things like that today, which is just unfathomable to me. So anyway, Kelsey had a lot to do with this presentation. She made, when you see a really nice slide, that's one that she made, not me. So, okay, so thanks, Kelsey. So I'm going to, I guess I will take the microphone because I'm going to have to move around a little bit. And there's a disclaimer. I begin with a disclaimer, several of them, in fact. Characteristics of the talk. It suggests it's not a well-developed field, as you'll see, the cartography of permafrost. It's suggestive in most respects. It's very open-ended. We're just getting a start on a lot of this stuff, and the progress is slow, as you'll see. It is inconclusive, and it is, and I should emphasize this, it's not a critique of individuals or their map products. It's more a general critique of the way things have been done and the lack of an interface, really, between permafrost scientists and cartography. The intent is to point out some issues that, with rare exceptions, are rarely discussed in the permafrost literature. And again, you'll see some evidence of this. So fundamental question, this comes from Jerry Brown, who was the president of the International Permafrost Association at the time that he asked this rhetorical question. Are the present criteria for permafrost mapping useful for 21st century scenarios? And you can kind of be the judge of some of this at the end of this. Jerry and I are close colleagues. He worked for the U.S. Army's Cold Regions Research and Engineering Lab for many years, and then transferred to within the federal government to the National Science Foundation Office of Polar Programs, and we'll probably see a bit of his work in this. Well, the answer to the question that we just posed, are the present criteria for permafrost mapping useful in the 21st century scenario? And the answer, the tongue-in-cheek answer, is many a nicer than March self-importantly with terra incognita. And the alternative statement of that is there's always room for improvement. And I think you'll probably agree with me at the end of the talk that that is indeed the case. So I have to start out a little bit about with a few definitions, just simple definitions of permafrost. What is it? Permafrost is any bolded there subsurface earth materials that remain at or below 0 degrees C, freezing point of water, continuously for 2 or more years. And the second definition up here is the active layer. And this is really where I spent much of my professional career working on the active layer. It's the layer of ground above permafrost that freezes and thaws each year. Okay, so just kind of hang on to those definitions because we're going to be seeing them a lot. I've got my little pointer here. Another concept that's going to come up is that of degree days of freezing and thawing. You probably heard of degree days of heating and cooling in buildings and cities. Well, all we're looking at here, the simplest way to define, for example, the degree days of thawing would be, okay, this line, this horizontal line is the mean annual temperature of 0 degrees Celsius. And the way to derive this, the simplest one, if you have your data loggers working, is to sum the mean daily temperature from the onset of thaw until the end of thaw, the onset of freezing. And freezing, the degree days of freezing are similarly, it's almost a mirror image across this axis. Okay, so we'll run into that as we come on. Another very important distinction is between ice-rich and dry permafrost. And looking ahead a little bit into the talk, what we're going to find out is that ice-rich permafrost can cause a lot of problems. The infrastructure that's standing on it, to building things on it, we'll see some evidence of that. And ice-rich, well, we'll see in the next slide. Dry permafrost, on the other hand, since there's no water substance in it, it's not really a problem for construction or anything. There's subsidence doesn't occur on it because there's no phase change of material. So, excuse me while I take care of my dry mouth. Okay, well, this is just an example of what ice-rich terrain can look like. This is an extreme example. It's from the Yamal Peninsula in northern Siberia, and what this is in fact buried glacier ice. So that accounts for the thickness of this. But as you can imagine, if that ice is to melt, and it is melting there, you can see a lot of material that has cascaded and moved down the ice face out here. I was out in some tall boots one day, this very day, and got stuck up to my knees. A couple of people had to pull me out. It's so muddy. Okay, well, there was an experiment, as we'll see, in the 1940s when the Alcan, now the Alaska Highway, was constructed in the early 40s as part of a military program to shore up Alaska in terms of defense. The importance of permafrost became very apparent to the Army and to the government in general. And the New Fairbanks, they had the National Permafrost Testing Facility in the late 1940s. It went on a very simple experiment. This is a natural surface right here with trees and underbrush and understory. And they came out and they cut the big trees down here. The trees and the brush were removed. And over in this section, they took a bulldozer and just bladed everything off right down to the bare soil. And so if you look at this horizontal line, that is the ground surface, obviously. Moss and peat, really important thermal insulators. And the original permafrost surface, which kind of, in many cases, mocks or reflects the ground surface, but farther down. The original permafrost surface was a little over a meter deep. And after 5 years, the permafrost surface had gone down to almost 3 meters, 3.6 after 10 years, after 15 years, 4.7. After 26 years, the permafrost had receded almost 7 meters, just from a simple change of the vegetation. And this is one that's near and dear to my heart. My academic grandfather, J. Ross Mackay at the University of British Columbia, worked in the Mackenzie Delta way up in northwest Canada. And he was in Newberry and was just walking by somebody's house and saw this dog that was chained to a post. And he noticed that the vegetation, this dog just trotting around as dogs do, and he had destroyed all of the vegetation completely. So over a 5-year period, Ross took a deep-side alidade and just made this little map. And there was as much as 15, 20 centimeters of subsidence. It was ice-rich permafrost again. And he made a nice little contour map. So you can see it's very sensitive just from a dog padding around. Now, he probably did a little digging too. Ross didn't mention that. So some peculiar features of permafrost regions. We're going to need some of this, but they are fascinating. These are called oriented lakes, and you can see that they're not only elongated, but they're all pointing in the same direction. And the reason for that is that you have continuous offshore winds, sea breeze, during the summer, because it doesn't get dark in the summertime. So you have very persistent winds that come out, blow perpendicular to these lakes. It sets up a 2-cell circulation. And it's the ends of the lakes that are eroded, and they're eroded very easily because of ice-rich permafrost. So that's a very common feature. Another one is a pingo. This, again, Ross Mackay worked on these, solved the problem of the things that in the Inupiat language of northwestern Canada, I can't remember exactly how to pronounce it, but it means in English, the fourth thing that is growing. This is once one of those thaw lakes, as they're called. Oriented lakes are just oriented examples of thaw lakes. And a lake that is more than 6 feet, 2 meters deep, creates what we call a permafrost window. Okay, so below the surface, there's a depression of the permafrost table that might be quite a few meters below, because the lake has really insulated the subsurface from the full brunt of winter temperatures. So if the lake drains, and they sometimes do, not sometimes, they very often do, as a result of, it's just a natural cycle. And all of a sudden, the old lake bed is subjected to the cold temperatures in the winter. And the surface begins to freeze downward, and also from the sides, from the surrounding permafrost. And of course, because it was a lake previously, the sediments are very saturated. And what happens is you've got a pocket of saturated sediments with progressive freezing from all directions. And those sediments are subjected to increasing pressure through time. And finally, the pressure gets so great, the stress has to be relieved, and it does so in the direction of least resistance, which is upward. And a big ice core forms. And this hill is indeed ice core, is a nearly pure core of ice. Ross Mackay, I'll keep mentioning him, but he was just probably the best permafrost scientist that ever lived in North America. And he grew his own pingo by training a lake and just keeping track of everything. And he died recently, but there's no question that pingo was growing. So those are very interesting things. And cartographically, I'll probably use these as an example a couple times. The other thing, these are really amazing tessellations. These are called ice wedge polygons. We have a field of ice wedge polygons here. And this is something that, again, is a consequence of extreme winter cold, and it happens, they form over a long period of time. if you have a drop in temperature of about 20 degrees C over a very short period, a day or two, the sediments contract, the frozen sediments contract, and they crack. And it sounds almost like a gunshot. I've never been fortunate enough to be there when one did, but I've seen the results of that is crack develops, and in the spring, when the snow melts, it runs down into the crack and creates, not surprisingly, ice. And they take the form of big wedges, and they can reach huge dimensions. And there is terrain in Siberia that is probably 80% ice underneath it because the ice wedges have gotten so big. Okay, well, I want to talk a little bit about permafrost. And it's personal, this is a kind of a personal thing that until about 1990, and we'll see the reasons for this, permafrost was not on the radar of an awful lot of people. So I have had interviews where somebody told a journalist to contact me about this or that, and then talk about it. And this again was in the pre-90s, 30 years ago or so. And they ended up almost with an insult. Well, you know, this is a really obscure area of study. And when I will mention the institution, it was interviewing for a job, and of course, there's many, many different aspects to that, but one of them that always comes up to be money. Yeah, what's your salary going to be? So I was in discussions with the dean about this, and what do you want to have? She said, and I said, well, I'd like to have this much. And she said, well, you understand, don't you, that you're in a really obscure area of science. And that was her excuse for keeping me down. Well, no more. We did used to go around hollering, oh, we don't get no respect, but that's no longer the case. And the reason for that is that the permafrost front and center in climate change studies. And the cryosphere, a word that I'll use several times, consists of cold regions phenomena, glaciers, lake, river, and sea ice, snow, and permafrost. Well, permafrost has three major roles in climate change research. The first one up at the top is just a diagram that was published by another great permafrost scientist, Art Lockenbrook, back in the mid-80s, and he had put temperature sensors down into very deep into boreholes that the oil companies had left behind. And people, this in Russian science, some of this had been done too, but this was a really splashy study in the journal Science in 1986. And you can look at the history of temperature evolution in the subsurface over a period of up to maybe a little bit more than a century. Now, the second role is that permafrost can translate the effects of climatic warming, and the next few slides will show some examples of that. And the third one is that permafrost can facilitate the effects of climate change because there's an awful lot of carbon, CO2, methane, that is sequestered in permafrost. And as the depth of thaw increases, and carbon gets liberated, and microbial action ends up sending it out into the atmosphere. And the carbon stocks in the Arctic are huge, and there are increases in the fluxes of carbon. But I just wanted to show this just for kind of a sexy, excuse me a second, a splashy kind of thing that we're seeing all around the Northern Hemisphere. These photos are from Fairbanks, Alaska, and with the exception of the one in the upper left, I took all these photos about 10 years ago. This is a subdivision that was built probably in the late 1950s, if I recall correctly. The basements, or just in the first floor, they're uninsulated. So there's a lot of heat leak into the substrate. And ground ice is not distributed uniformly, as you can see from this. So as these buildings, as the ground ice melts, these buildings settle differentially and leading to some real problems. And the upper left there, people should have known better. This is again Fairbanks, the University of Alaska Fairbanks campus in the parking lot for the geophysical institute. And they use black asphalt. What do you expect, guys? And the upper right is an apartment complex in Siberia that experienced. I'm not sure, I'm not going to attribute this to climate change, but it certainly didn't help. But improper heating and Soviet designs were pretty good for this kind of building, but they based their plans on temperature in the last 20, 30, 40 years, and it's exceeded that now. So that has contributed to collapse of quite a few buildings. In the lower left, you have a boiler house, again, with an uninsulated floor in Mongolia. And on the right, this is one that is very interesting to me. There are formulae that you can use to predict the amount of gravel that you need to insulate the surface. This is in Prudhoe Bay, Alaska, taken a long time ago, and not long after the development of Prudhoe Bay took place. And what you can see very clearly is that they didn't use the formulas that were available to them to tell them what the necessary thickness of gravel fill would be. And what you're looking at, these little ponds, those are ice wedges, or Friends ice wedges, which are nearly pure ice inclusions. Oops, got the wrong one there, sorry. These are very standard in most respects situation in Russia for housing your cars, but some poor unfortunates put their cars in exactly the wrong place. And they're doing a little nosedive. Okay, well, let's move on to some of the mapping material. The most common circumpolar map of permafrost distribution divides the ground surface at small geographical scales, large areas, into zones of permafrost in which the permafrost is continuous or somehow discontinuous or sporadic. And I'm going to spend some time discussing those terms because they are very poorly defined. And they're usually poorly defined, and they are conflict with one another. But anyway, this is a standard kind of depiction of the distribution of permafrost. Pretty map. They look much better than they did in the old days. And again, I mentioned Jerry Brown. He put together a map with the help of a lot of people from a lot of countries that for the first time, and this was 1997, used the same criteria in a lot of different places, took data from a lot of different countries and was able to put it together and at least come up with some mapping rules, which has not always been the case. The theoretical distribution of permafrost is really a consequence of incoming solar radiation. Up near the pole, very, very cold, and we're not considering the juxtaposition of land and water in this perfect terrestrial surface. So this is what the distribution of permafrost would look like under this continuous, discontinuous, sporadic thing. But the juxtaposition of land and water and vegetation, differences in thermal properties of the soil and the amounts of water substance in the substrate makes these borders a lot less smooth than they are here. Well, let's just look at this in a profile. On the left here, we are at the Arctic Ocean up at Prudhoe Bay, Alaska, and the permafrost here is, what does it say, 600 and some feet thick. And the active layer progressively goes, as you might expect, from being very thin because of warm summers, down towards the south, a little bit north of Anchorage, become quite thick. But the other thing that this illustrates is this idea of continuity. Permafrost is is continuous on the north slope of Alaska. And down in the latitude of Fairbanks, it breaks up. And some of this is contemporary climate, and a lot of it is permafrost is relic, which makes the problem both more interesting and more difficult. And in the southern part, not far from Anchorage, permafrost ends up just being small patches. Okay, I always have to say this. One of my very first graduate students was a guy from Leningrad, and he said, in any talk that you ever give, he told me this, you need to give credit to Russians. And so virtually every talk that I do this. I quote a 1912 from a 1912 construction manual. We should not be afraid of accusations of Russian chauvinism and admit that the pride of first discovery and investigation of permafrost belongs to Russian scientists. Not a particularly modest declaration, but absolutely true. And I bring up another person here. This is I'm going to try and lace this this talk with little stories. This is a woman that I met in 2016 at one of the international permafrost conferences. I didn't know anything about her or her work. She got a doctorate in history from Princeton University. She had spent almost 2 years in Russia. She's extremely fluent in Russian. And she worked in archives and libraries, mostly in Moscow and St. Petersburg, and came up with just a remarkable book. So if you're ever interested, if you are interested in this sort of thing, it's a fascinating book. But she goes back just to the original investigations in Siberia. And it's an amazing book, but it's a very strange thing. It has been reviewed once in permafrost literature, and probably about 10 times in the literature of the humanities. So once again, we see this kind of parting of very important work from your run-of-the-mill day-to-day permafrost scientists like me. Anyway, she is currently at Pomona College and is just an absolutely remarkable person. And a lot of my own historical work is somewhat dependent on hers. So some permafrost mapping history. Again, just a reminder, permafrost is a subsurface earth material that remains at or below the freezing point of water for 2 or more consecutive years. And this is a very important quote from my friend Stefan Gruber. Permafrost is a clandestine, has a clandestine character. It's subsurface. You see some manifestations of it in a lot of places, but at the surface you don't always. And this is one of the real difficulties involved in trying to work with it. It's, you don't know, it's always there. And it's very laborious, very costly to find out if it is. So this is just some stuff from Pay's work. The first mention of permafrost of any importance was Chevron's well in the 1700s in Yakutsk, where the governors had to go out and dig a water well, and they got down 100 meters. It was still no water after 5 or 10 years. And they sent scientific parties out from all over the place. People from the UK came and looked at this. It was a wonder of the world. People didn't believe it, so they'd send somebody from another country, and it was finally written up in Nature, the journal Nature. And that's pretty important. So this is just the first example of some things I'm going to show you, that what these lines, colored lines and dashed lines, represent are the southern limit of permafrost in Siberia. And so again, in 1927, published an important book. Now, realized the Russian Revolution had happened by this time. And just about everything was political, and like it is here now. But so again, put forward a permafrost classification that lent itself to mapping. And there were several competing schemes. Hudson again was an important party member, and he prevailed on this. And what's amazing is his classification is still in play. So the Russians had lots and lots of experience with permafrost, even in Tsarist times. The construction of the Trans-Siberian Railway is the premier example, and those folks really kept good records. You can still find data archives in St. Petersburg about this. Just really amazing, a huge, huge effort. And here's a picture of the man himself. And there's an anonymous English summary of Sundin's 1927 Ever Frozen Soil of the USSR, his book, in the journal Nature in 1929. And that caused a little bit of a stir. Well, frozen ground, but that's Siberia. And let's not worry about it too much. Well, meanwhile, in North America, this is really interesting, that in around the turn of the 20th century, with the Klondike Gold Rush, there were some experiences with permafrost, and a few things found their way into scientific journals, mostly having to do with mining. So they would inject steam into the subsurface. That was one method. Turn fire hose on exposure, on vertical exposure to be melted. But still, its importance and its presence was not particularly well known until the early 1940s, when there was great fear of a Japanese incursion into Alaska, which ultimately happened in the Aleutian Islands. But they said, we really have to have a road to Alaska. So they moved something on the order of 11,000 U.S. Army troops. And each company was given a couple of bulldozers and a sawmill and this and that, and so many trucks and so many caterpillars, but they had not paid any attention to the sort of thing that I opened with one of the opening slides about what happens when you remove the vegetation from the surface. They went in with caterpillars, knocked down the trees, and built a 1,500-mile road that it was constructed in, I think it was 8 months, and was already having trouble as a result of thaw subsidence and melting of ground ice. And at that point, they realized we really need to do something. This thing is very, very important. And so they enlisted the help of a guy on the left there named Simon Muller. Now that is not really a Russian sounding name. His father was a telegraph construction guy on the Trans-Siberian Railroad, but he was born, in Russia, was raised as a Russian boy into adulthood. And at the time of the 1917 revolution, where did he have the misfortune of being? What did he have the misfortune of being? He was a cadet in the Tsar's Navy, which probably not a good place to be at that time. And after the war between the whites and the reds, he got the heck out of Vladivostok, which was where he was posted, and escaped to China, and then worked his way as a purser on a trans-Pacific steamer of some kind, and ended up in California and studied geology at Stanford University. Well, he was obviously very fluent in Russian. He had the necessary background. Knew a lot about sediments, various things. I don't know how much physical insight he had, but he was taken from his faculty position, sent to Washington, D.C. to use the U.S. Geological Survey's library, and he constructed in about 6 months a permafrost manual that was given in parts because of security concerns for bridge builders, for road surfacers, and different things. And as you can see from this, it was highly restricted. But he said he summarized the Russian literature and came up with a very effective construction manual. that the Army could follow. So in the following year, 1943, the road was repaired and rerouted in some cases to get away from ice-rich areas. And it has worked pretty well. It was at that time called the Elkhorn Highway for obvious reasons. It's now the Alaska Highway and has a huge volume of traffic. And in 1947, the manual was declassified and it was published by Edwards Brothers in Ann Arbor, Michigan, and got a pretty widespread distribution. I started studying permafrost in about 1975, and this was just about the only textbook that was there, 1947 thing. But he just borrowed one of the Soviet maps with discontinuous, continuous, sporadic classification, and that has reinforced it. But an interesting aside to this is that when the thing was declassified, it came out, and of course, we and the Soviets were spying on one another constantly. And the fact that this was all based on Soviet literature was used for military purposes in the United States inspired the wrath of Joseph Stalin. And he came to Moscow State University, but he didn't come there himself, but he sent people, and they had a lockdown of the department. And if you were in there, if you were going in there and going out, you had your briefcase searched and all sorts of things. So permafrost was given a lot of import back in those days. Well, just take a quick look at the amount of money that has gone into during the Cold War into Arctic research. And I think I just changed this the other day. This is a 1968 article, and this is the whole span. It's not just permafrost, but at least in 1968, in current contemporary dollars, it was $135 billion. A lot of money. The upper right, this is a place that I've worked at a lot, Barrel. In fact, some of these concepts, it's a Naval Arctic Research Lab. Some of those concepts are still standing and stayed there quite a bit. Not something you really want to do. They're pretty old. Okay, so today's permafrost maps are data intensive, not surprising. The products of GIS types of manipulations, and they're drawn by means of automated cartography, which I sometimes think of as autopilot cartography. And if you go through the literature of cartography, there has been increasing concern over the last 20 years about desktop mapping by non-specialists. It's sometimes called a democratization of cartography. But, there's often very little expertise that goes into this. And I guess I'm suggesting in a mild way that permafrost scientists have been part of this for whatever reason. I think most permafrost scientists come from engineering backgrounds, geological background, and not so much geography. Wouldn't have ended up with a lot of cartographic expertise. And so there's a real divide between a lot of the work that goes on, geophysical work in the detection of permafrost and looking at the processes in it, and the way that it's presented cartographically. So I just talked a little bit about some cartographic lore. Before there was GIS, there was analytic cartography. I know some of you have heard that term. This was the brainchild of a very great intellect by the name of Walter Tobler. And his student, well, actually his replacement at the University of California, Santa Barbara, wrote a book on analytic cartography. I actually have these quotes backward, but I'll read the top one. Analytical cartography is in 1976 that the term was coined. Treats the theoretical and mathematical background between cartography and the rules cartographers employ in the mapping process. So it's not just a simple mapping listing of objects, but actually using these things as mathematical tools. And Tobler himself, in this article in 1976, where he introduced the term, said the purpose of analytical cartography is the development of geographic theory, not the inventorying of geographical phenomena. So it is indeed a small world. Walter Tobler was a Swiss citizen. He was a young lad, probably a teenager, and his father got employment in the Swiss embassy in Vancouver. And so he went to work in Vancouver, and when he turned 18, he started his studies at the University of British Columbia. And there was a gentleman, that name again, J. Ross Mackay, who was a professor at the University of British Columbia. And he had cut his IT as a cartographer. He's a brilliant guy. He spent 2 years Japanese alone in a Japanese occupied island in the Pacific during World War II. He was the product of a marriage by a Scot and a Chinese. And so he was raised part of his early childhood in China, but he was educated in Japan. So he had really good knowledge of the Japanese language. And he was, for that reason, put on this island. Just an amazing man. And he is the only person who had a Canadian naval vessel, albeit a small one, that was named for him while he was alive. That's never happened before or after. It's a pretty small boat, but it's a pretty impressive thing that he's the only one. So anyway, here's Tobler, freshman, brash, smart guy, speaks German really well, came to Ross Mackay and said, I'd like to take your advanced cartography course. Mackay said, well, you're a freshman, why would you do that? And I think probably Mackay had a funny sense of humor, so he probably just let him in and see what would happen. And it turns out that Tobler did extremely well. And Mackay told him, you probably should go down to the University of Washington and finish up your degree. There's a lot of very, very analytic and quantitative geography. So this was the late 50s. So this was cutting edge time application of statistical methods designed for locational data. So Tobler did just that, and the rest was history. Got a job at the University of Michigan, stayed there 20-some years. It's just absolutely remarkable guy, and he moved to the University of California in Santa Barbara, where they had a really, really solid quantitative geography department. And he's absolutely brilliant. I don't need to say anything more about him now, but this is an illustration of something I was just talking about a couple of minutes ago. Permafrost scientists and have not availed themselves theory or really anything cartographic. So probably about 20 years ago, I attended a workshop, a several-day workshop in the University of Alaska Fairbanks that was concerned with modeling the spatial distribution of permafrost. All good and fine. But when I gave a talk. I had submitted an abstract on the cartography of permafrost. It was really the first example of what I'm talking about today. And the guy who introduced me, who was also the workshop organizer, said the following. Well, this is Fritz, and he's from such and such, and the name of his paper is Cartography of Permafrost. You may wonder why someone at a workshop on spatially distributed permafrost modeling is talking about cartography. But you have to remember that our products involve maps, so I think it's appropriate. Pretty amazing stuff. Representations of permafrost continuity are in most cases choropleth, i.e. graded series maps, despite the use of radically different classification methods, that criteria that include the percentage of the land area underlaying permafrost. That's a real hit measure. How do you get a good estimate of that? It being as Stefan said, clandestine phenomena. Well, you can bore into it and use temperature, permafrost thickness, and sometimes even the landforms that I showed earlier can be used because they are correlated to some degree with climate severity. They've been used. The resulting maps, though, even though they're radically different criteria for their constructions, always depict permafrost continuity. So, yeah, it's kind of weird. Consider for the moment the nature of boundaries. And yeah, one is astronomical. You can go up the Dalton Highway north of Fairbanks on your way to Peru Bay and cross the Arctic Circle. So that's a sort of a boundary. You can lay this out nicely. So you can stand north and south simultaneously of the Arctic Circle. And this one is a little bit more interesting. This is in the shared space of northern Norway and northern Finland. And boy, that's a nice boundary as you could ever imagine. Well, what is that? It's a big fence. And the Finns are known to cultivate reindeer. And the Norwegians not so much. So what you're looking at there is the difference in grazing policy in the two countries. So that's a boundary of sorts, but I can't think of too many other examples where you, other than political boundaries, where you can really see this stuff. Wow, this overwhelming slide, I'll just tell you what it is. There are, in fact, 3 of these, all different, in this article by Alan Hagenbottom, who was concerned with permafrost mapping. He worked for the Geological Survey of Canada. Really nice guy, smart guy, and he just died recently, sadly. But all of these, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 studies, and there's 3 like this. So there's probably 35 different studies that he went over, and they're all concerned with mapping boundaries between the boundaries, in quotes, between continuous and discontinuous and sporadic permafrost. Okay, well, let's look at mapping from a more theoretical standpoint. This is a typology of maps. This has been around for quite a while. And what you're looking at here is level measurement, nominal, ordinal, and ratio. And you're looking at the dimensions of the maps. And this is a very helpful thing in the construction of maps of almost any kind. So I mentioned Pingo's point map will be something at the upper left there. And I'm not going to go through all these things, just going down to the nominal stuff. Ordinal, let's just say that's a map of cities, larger cities, smaller cities. Interval ratios would be the actual numbers. So draw proportional to the size. Looking at the area maps, I've used permafrost here. At the nominal scale, you can say, well, you have permafrost, you have seasonal frost, and you have no frost. Going down further, and that is the crux of the matter, looking at that center, and this is what the maps of permafrost continuity are at the class, and they are ordinal maps and over areas. So moving right along, the operationalization of this is a series of maps that were made of obviously Eastern Canada over the years. Well, let's just look from 1974 to 1988, 1990. Not too big a spread of time, but I can tell you that the permafrost has not migrated in that period of time. They really were known in these different maps. They didn't really tell you in the text what criteria were being used. And so this is one of my bugaboos. I did publish this and to very little in the way of accolades. I used another map, this one of Alaska, where it mixes the continuity classification with all kinds of other things, vegetation and stuff. And it's really very difficult to wade your way into that. Now, this, I think, is an interesting. The Soviet Union, even into the 1980s, they didn't have much in the way of geographic information systems. I would mention that over, and they would say, "What's that?" But in effect, they're permafrost maps. Look at this is a legend for the thing. They were really data layers here, and well, you're very familiar with the Cold War, many of you. In 1984, our CIA got hold of some of these Russian maps and decided that permafrost was important for trackability studies of tanks and various things. And they made a map. And what did they do? They dumbed it down to Soviet's classification for reasons I don't know. Okay, so I was reading some social science literature, and I came to the realization that this continuity classification really is what some of the social scientists call a rascal concept. Although the majority of contemporary works employ variants of continuity cartographic strategy, it amounts to a rascal concept. Pervasive, inconsistently defined, empirically imprecise, arbitrary, inconsistently applied, and frequently contested. Nobody ever talks about it. Okay, so I'm heading towards the home stretch here. I realize I'm getting close to going over. But these are two maps that were made with identical data in the mid-1990s, purporting to show the same thing. The map on the right, the cartographer had in mind just some kind of choroplast model. And so he classed these active layer. I think that's what these maps are according to show. And it's sort of a strange looking document, although it was published in a reputable journal. The map on the left used a spectral progression and incorporated a digital elevation model. And just take a quick look at how this thing was constructed. There was a series of temperature monitoring stations. This is the Cartographic River Basin in northern Alaska. Several stations here, air temperature. The active layer was monitored here both thermally and through probing to the top of the permafrost. And sorry about this. This was subject to a series of data layers that include interpolation, the thawing degree days, and the land cover, and the topography, very important. We ended up with a map that not only, I think it's kind of pretty, but it was pretty darn accurate. We spent 2 weeks on the helicopter going out verifying this thing. And it was probably about 85% accurate at that time. I'm going to skip over some of this stuff. Some of you know or know of a great cartographer named Mark von Menier. And he published an entire book, 2 volumes, as far as I know, two editions. And there's several kinds of cartographic lines: omission, commission, you all heard that from your parents. Intentional maps, we see that a lot. And unintentional, which he also called blunders that mislead. And I would put this continuity-based thing in that category. Oops, sorry about that. So until this climate change stuff really started to come up, this is me talking 30 years ago, I think. Little harm is done through a publication of various small-scale permafrost maps, except perhaps to foster the notion that thematic cartography is an inexact or even whimsical endeavor. With the advent of concerns about global warming, however, small-scale permafrost mapping has entered a new stage in which explicit mapping criteria and replicability are of central concern. Comparison of the present-day distribution of permafrost with estimates of its aerial extent during glacial maxima or minima and under various climate change scenarios demands rigorous, explicitly stated criteria for placement of zone boundaries. Our collective failure to use the full potential of tools and techniques of contemporary cartographic and spatial analytic theory makes possible affects our ability to effectively and accurately communicate the impacts and hazards associated with thawing permafrost in the larger context of global change. So, summarize. Permafrost zones should be treated cartographically as fuzzy boundaries rather than sharp lines. They're transitional zones. Published maps very often use inconsistent mapping criteria. Published maps of the same area can be wildly divergent. Continuity-based mapping may be ineffective for representing geocryological, that is to say, permafrost situations arising from rapid climate change. You need really spatio-temporal methods, scale issues. So find in the literature references to patches of continuous permafrost. I would maintain that this type of mapping is not necessarily scale independent and a modifiable aerial unit problem, which is a big deal in things like statistical treatment of, excuse me, my mouth's really dry, of the census data. So, the fundamental question follows, are continuity classes the best mapping criteria? And a large number of investigators have conceptualized permafrost-related mapping in terms of probabilities of the existence of permafrost. But when it comes to the actual cartographic display of these probabilities, the data are often transformed into the continuity classes. Reasons I don't know. So I'm going to just skip over this. I know I'm running out of time. Cartographic visualization possibilities that be applied in permafrost science. I've already covered this thing. I'm just talking here a little bit about certain landforms and various things. So I'll take the second from the left column. Line maps at a nominal scale, which is B. Easy one would be highway maps. At an ordinal scale, some things are larger than others. You see this all the time. We're used to when people use paper maps. Traffic flow. So the red map, the red lines indicate heavier traffic flow, more well-traveled routes. And then at the bottom of that column, this would be traffic cars per day and that kind of thing. Well, we can come up with exactly the same sorts of things in the next column having to do with permafrost, and I've already covered some of that. Interpolation on a spherical lattice, we all know in map society that it's very difficult to represent a spherical surface on a flat map. And I'm not going to go into details, but the discussion about Greenland in recent weeks has exactly that. It's as big as Africa. A Mercator prediction. Okay, tessellations, and this is something that really could be applied to get the best kinds of interpolations, be they hexagons, rectangles, whatever, but it should be adjusted and chosen for the phenomena. Uncertainty has become a hot topic in cartography and has been so for probably 15 or 20 years. And uncertainty would be really useful to show to accompany permafrost maps, because permafrost data almost always come from clustered areas that's dependent on ease of transportation. It costs a lot to helicopter people in. And the use of color could be probably better, as one of the maps that I showed a little while ago. Three-dimensional mapping at local scales. This is a ground penetrating radar survey of an area, again in northern Alaska, and there at there is the subsurface exists occurrence of a system of ice-wedge polygons. Our old friends, there's no shortage of information. These are a bunch of textbooks in cartography that can never take hold in permafrost science, as well as primary journals that just looking through some of these things, there's just huge applications for them. So I'll end up with a few recommendations. The use of appropriate sampling methodology is extremely both for the creation of empirical maps and for the validation of modeling efforts. And this is becoming increasingly important. Type of map. I'm sorry, I'm going to step back here. I'm having trouble reading everything. The type of map chosen should reflect the nature, i.e., the nature, the level of measurement of the underlying data set. Generalizations employed should be appropriate to the statistical characteristics of the underlying data set. Cartographic transformations and GIS manipulations should be explained in the text of scientific papers and included with metadata describing archive cartographic products. You don't see this very much. Make use of signatures with cartographic knowledge and advice that are available. Extremely important. A lot of folks read the last 20 years of literature and not very much more. Okay, this is something that if you had asked me about it 2 years ago, I would say, well, I'm old and I'm reactionary, but artificial intelligence, you hear an awful lot about this stuff, and the term is becoming very, very advanced. And I think there are great applications for our science, and this is probably the last point I'm going to leave you with. That slide in 1989 of the party where each participant was given a chilled liter of vodka along with some fish. And it was really a way of Soviet and North American and Western Europeans getting together and talking about permafrost. And this had not happened, or it happened in very limited fashion. I first went to the Soviet Union, to Leningrad, in 1988. Spent the summer of 1989 there. And I was one of the first permafrost scientists, certainly. And I don't know of a lot of others, but I lived as Soviet man. I had my own apartment and worked at the State Hydrological Institute. And it was just a tremendously profitable, because each side brought to the table a different skill set, a different knowledge set. And it worked magnificently well. And it's really, I would say, the high mark of my career was the 25, 30 years that I worked with first Soviet and then Russian scientists. Great friendships. And oh, yeah, I'm sorry. I thought I showed this slide a little while ago. Yeah, the epilogue, the reuniting of North American and Russian permafrost scientists at the end of the Cold War. So I've said some words. This is a Tucker party where look at the bottles of vodka. You can just avail yourself of that. And all of the sessions and the conference workshop the next day were canceled. And the organizers were thrown in jail. And the American and Canadians went down to the local jail and said, to get drunk. They were just not giving us what we wanted. So it was just a wonderful time. But a renewed Cold War is on with permafrost science is one of the real, for me, a real casualty. Russian nationals are currently suspended from participating in the events, and as you say, the conferences of the International Permafrost Association, and data acquisition or data transfer to big archives in the West and just dried up. So it's, to me, a tragic situation. And, I think that the invasion of Ukraine was a terrible, terrible thing. We need to do something about Putin, but I don't know if this is really the way of achieving results. Okay, so finally, thank you very much for your let's see from this list of acknowledgements. I have been working with a lot of Russians over the years, and it's great. Okay.
All right, thank you, Brett. We have probably time for half a question. Question.
I have a question.
All right.
I'm just very curious about the basic data. Where does it come from? I mean, there must be 100,000 weather stations in permafrost areas that can give you the surface temperature all during the year. Can you get something from imaging from outer space? Or do you need a probe that goes down 100 meters, you know, and gives you recordings of the whole? I don't understand how you get to the data.
Well, this has to do with climate estimation of permafrost, and people really are working on remotely sensed approaches to detecting its presence and thermal properties, and I think that's what the active there. But on your question, I don't think there's hundreds of thousands of weather stations in the permafrost regions. Not that I'm aware of. But
Well, however many there are,
Yeah.
would the surface temperature tell you that much?
surface temperature is a parameter that is sadly neglected. You can look into the literature around the United States, and there's just not very many places that monitor that. Even in the Soviet Union, where they had, you know, full employment, shall we say, there were a lot of people doing permafrost stuff. A lot of it had to do with digging and looking at the stratigraphy and that kind of thing. There were a few sites that were by some kind of mandate by hydromet, I think, which is the government organization, looking at surface temperature, but still not a lot. And those are precious data sets. Yeah, so it's sparse. We've been working on the active layer. I didn't talk a lot about this, but in 1990, we set up a certain called active layer monitoring program, starting in the last decade. It grew quite large, got a lot of Russian people on it. And it currently has, if you keep the Russian sites in, they will come back. About 250 sites in both polar regions. And we monitor surface temperature, ground temperature, temperature at 50 centimeters below the surface, big vegetation maps. We have a lot of people at that. So it's 250. 250 for that vast area. And that's a denser level than this, but again, it has spectacular shortcomings relating to transportation. How the heck do you get to these places? Going in on helicopters. And so, yeah, it's very sparse coverage, and it's also clustered because stuff is done around transportation corridors. Thank you. Thanks.
All right, thank you. I'll let you ask your questions to him after we finish. So thanks all for coming. See you next month.
The Antarctic, they don't have permafrost. Do they? There was an actual.
Yeah.
I sent you the book.